Hi, welcome to Mrs. Park's Algebra 1 class. This is lesson 5.5, Inequalities involving absolute value. Okay, so when we have absolute values and inequalities, when you have an inequality that involves less than, okay, the inequality, absolute value of x is less than 3, means that the distance between x and 0 is less than 3. It doesn't necessarily mean is just less than 3. The distance, remember absolute value means distance. So it can be from 0, it can be 3 from 0 to the right, or it can be 3 from 0 to the left. It's still 3 no matter which way you go, the distance is still 3. So the answer set is x is greater than -3 and x is less than 3. So you have two possibilities here. X is less than -3 or x is greater than -3 or x is less than 3. So when solving absolute value inequalities, these are two cases to consider. One, the expression inside the absolute value symbol is non-negative. And two, the expression inside the absolute value symbol is negative. Okay. The solution is the union of the solutions of these two cases. Okay, and we'll find out what that means a little bit more in detail when we try some problems. Okay, so when you have a problem like this, absolute value of m plus 2 is less than 11. So there's two cases here. You can say this inside the absolute value is non-negative, or you can say it's negative. So in that case, m plus 2 is 11, and you solve for m by subtracting 2 on each side, and there's your answer there. Or you can also say m plus 2 is less than -11. Okay? In that case, I'm sorry, so this inside is negative, it's less than 11. Let me repeat that again. So m plus 2, this entire thing inside, is a negative, and that's less than 11. So when that happens, I'm going to just get rid of that negative by moving it to this side. And what they did was divide by negative 1 on each side, and then switch the sign. So now you have m plus 2 is greater than -11. Subtract 2 to each side, and you have m is greater than -13. So the solution set is the union of these two. So m is greater than -13, but less than 9. And here is your final answer, what you will write. And here is your graph for the union of those two. Okay. So two cases here. This inside can be positive, or this can also be negative. Okay. What's inside the absolute value can be a non-negative, and it can also be a negative. You solve for both cases. Okay. So if you have a inequality such as this, there's no such thing, because anything that's in absolute value form, it has to be greater than 0. So it cannot be a negative number. There's no such thing as an absolute value that's less than a negative number. So that cannot be negative. So it's not possible. So the solution set is an empty set. Or you can also write no solution. Okay, so this is your turn here. Go ahead and pause the video, do numbers 1 and 2. I'm going to just give you a little hint on this one. There's going to be two separate solution sets. You can write n minus 8, which is a positive, is less or equal to 2. And then on the other side, you're going to say solve for this can be negative. So if you have negative n minus 8 is less or equal to 2. Okay, so those are the two possibilities. Go ahead and solve for n and find your answer. Come back when you're done. All right, welcome back. Here is a real-world example applying absolute value inequalities. So here it is. Here's the word problem. Internet. A recent survey showed that 65% of young adults watch online video clips. The margin of error was within 3 percentage points. Find a range of young adults who use video sharing sites. Okay, this is probably, this survey was probably taken a few years ago because I'm guessing now it's about like 99% of young adults watch videos online, video clips. All right, so it's 65%. So when they say there's an error, a margin error within 3%, that means give or take 3%. So before we write all this out, we know it's give or take 3%. So if you take 3%, that is 62. If you give 3%, that's going to be 68. All right, but let's see how we wrote this out. The difference between the actual number of viewers and the number from the survey is less than or equal to 3. Okay, so within 3 means less or equal to 3. That makes sense. So when we solve this, the absolute value of x minus 65 is less or equal to 3. So there's two cases. You can say this is positive or this is negative. So when it's positive, you have x minus 65 is less or equal to 3, and you solve for x. When it's negative, you're saying negative x minus 65 is less or equal to 3, and you solve for x. And then we just combine those two together. Okay, here's another your turn. Go ahead and pause the video, solve the problem, and come back. All right, welcome back. Here is the second portion. Absolute value inequalities. This time we're looking at when it's greater. The inequality, absolute value of x is greater than 3, means that the distance between x and 0 is greater than 3. So it's not within, now it's greater. So it's anything bigger going each way. Remember when it was less than, it was within the distance. Now we're talking about the distance is greater than 3. Again, there's two possible scenarios or cases. One is non-negative and one is negative. All right, so when we solve these problems, we're going to solve for when this is a positive or non-negative and when this is a negative. So 3n plus 6 is greater or equal to 12. Subtract 6 on each side to cancel that out. You have 3n is greater or equal to 6. Divide by 3 on each side. N is greater or equal to 2. The other case is when 3n plus 6, what's inside the absolute value, is negative. So put that negative there. We're going to switch the sign because we want to get rid of that negative on the other side by dividing by negative 1 on each side. Then we subtracted, what they did was subtract 6 on each side. 3n is less or equal to negative 18. Divide by 3 on each side. N is less or equal to negative 6. So we have here solution set n is greater or equal to positive 2. And you have n is less or equal to negative 6. So n is greater or equal to positive 2, or n is less or equal to negative 6. Okay, so here's where it's your turn. Do numbers 4 and 5. And make sure you do it on a separate sheet of paper. And that will be the lesson for today, 5-5. Make sure you hand in that homework for full credit. Thanks for listening.